Hello everyone. In this webinar, I'll be talking about the new features that we're adding to Visual MODFLOW Flex 11.0. I'll quickly introduce myself. My name is Nick Lyle, and I'm the client-facing expert here at Waterloo Hydrogeologic. I'm responsible for our trainings, and I'm closely involved with the software development side as well. Our company offers a comprehensive suite of software used for managing environmental groundwater projects. Of course, I'll be talking today about Visual MODFLOW Flex, our numerical groundwater modeling interface, but we also offer Aquatest Pro, a software used for analyzing and interpreting pumping and slug test data, HydroGeoAnalyst, which is a database software used for managing, analyzing, and interpreting environmental data, and AquaChem, which is a database software used to manage and analyze water quality data. So a little bit about Visual MODFLOW Flex, for those of you who are unfamiliar. Flex is an industry-leading GUI for MODFLOW, which is the numerical groundwater flow code created by the U.S. Geological Survey, which it combines with additional related codes that groundwater modelers rely on. We support many different flavors of MODFLOW, such as MODFLOW 6, MODFLOW 2005, and MODFLOW USG. All these are seamlessly integrated in the program and can be switched in between on the fly. We bring together MODFLOW with other tools such as MT3DMS for contaminant transport modeling, MODPath for calculating flow lines, Zone Budget, which allows users to calculate subregional water budgets, and PEST, which is a tool for conducting inverse modeling. In Flex, we have tools for every step of the groundwater modeling process, starting from the creation of the conceptual model to the creation of the grid, which may be a structured grid or an unstructured grid. Flex allows you to create and edit model inputs, such as boundary conditions and flow properties, graphically on the screen. And once the model runs, Flex allows you to graphically visualize model outputs, such as contaminant plumes and the distribution of heads. So what have we added in the new version? In Visual MODFLOW Flex version 11.0, we've overhauled model import. We now use tools from the Python library FlowPy, which I'll talk about later, to do import. This has several advantages over our older method of model import. For one thing, we now support import of MODFLOW 6 and CWAT models. The import process is now modular. In older versions of Flex, all model elements had to be brought in during import, which was not always desirable and could sometimes cause stability issues. With the new modular import process, the user can choose which elements that they want to bring in, such as only bringing in the model grid. This will allow you to import unstructured grids for the first time, provided that they're in the DISV format and associated with the MODFLOW 6 simulation file. Other model elements are now also imported modularly. For example, the listed boundary conditions may now be brought in individually, as are the flow properties such as hydraulic conductivity and the initial heads, which we support for the LPF, UPW, and NPF packages, which are the most commonly used ones. For the first time, we now support importing solver settings, output control settings, and flow settings such as layer type and rewetting options. Here's an example of what the import form looks like in the interface. As you can see, you can individually select which model elements that you want to include or exclude during import. Note that if you have a grid imported, you can also now import these model elements separately from the model import step as well. So for example, during the define boundary conditions step, there are tools to import boundary conditions from model name files. As I mentioned, these improvements are made possible because we now use a proprietary Python library that's based on FlowPy, which is an increasingly popular Python library or bundle of code used for creating MODFLOW models. I can't say too much, but looking in the long term, we hope to increase the integration between Flex and FlowPy for later releases. As it stands, we're already using FlowPy code in other places on the back end on a limited scale in addition to import, and this will only increase with time. With this release, Visual MODFLOW Flex has become the first MODFLOW GUI to step into the Python era of groundwater modeling. In Flex 11, we've also made big additions for working with unstructured models. As I already mentioned, MODFLOW 6 models with unstructured grids in the DISV format may now be imported into Flex. If desired, the user can choose to import only the grid, which will allow advanced users to use outside tools to design an unstructured grid and then bring that grid into the interface. Flex 11 also introduces the unstructured numerical modeling workflow. In previous versions of Flex, unstructured grids were always created in the conceptual modeling workflow. With this release, you can create an unstructured grid at the start of the modeling process and assign model elements onto that grid, like with the numerical modeling workflow for structured grids. Okay, so I'll quickly demo these new features that we've brought in for Flex version 11. In this demo, I'm going to be importing one of the MODFLOW 6 example projects. This is the curvilinear unstructured model. So now notice when I press OK and I create my project, I've got the ability to select this unstructured numerical modeling workflow, which is new for Flex version 11. So in this workflow, I can either create a new unstructured grid from scratch, or I can import unstructured models that are associated with disk feed grids on MODFLOW 6 datasets. So I'll select this, I'll select the default options here, and in the define numerical model step here, here's where I have the option to actually import an unstructured model. So I'll select that option right there. And now I just need to find the simulation file for this MODFLOW 6 model. So I'll press browse, and I'll find the mfsim.nam file for this model. I'll select it and I'll press open. I'll leave the grid name on the default and I'll just press import. So Flex has read the model name file, and now I've got the options for what I want to bring into the model. Of course, I always need to bring in the model grid, but I can also bring in things like the flow properties, translation settings, solver and output control settings, as well as boundary conditions. And in fact, because this is a MODFLOW 6 model, I can even select within a boundary condition which boundary conditions of that type I want to bring in. But I'll just leave everything on the defaults, and I'll just bring in all the model elements by pressing import. So in only a minute or two, Flex has brought in all the different model elements, and I can see if I proceed to the define properties step that now we've got the grid in the interface. And if I select edit here, for example, with conductivity selected under the toolbox, we can see all of the imported cell-by-cell flow properties. This model is homogeneous. If I go to the define boundary conditions step, I can take a look at the different boundary conditions that are associated with this model. And as we can see, if I set this exaggeration to 0, that the geometry associated with the original disk feed grid has been honored and brought into the interface. So this allows me to design whatever kind of grid I want outside of the interface, using any tool that I want, and then using this new import option, I can bring it into Visual MODFLOW Flex. Of course, I can also run this model. So I'll select run type and single run. I'll leave the options on default here. I'll make this a steady state model. Now I can just translate and run. Now if I proceed to the view map step, we can see that we get our model results. This is everything that I wanted to show. I'll get back to the presentation. Of course, we've added other features in the Flex version 11. Flex now supports triangular irregular networks, or TINs. These can be imported into the model by importing points data objects or interpolated from point data objects that you already have in the model. TINs can be used for the same things that existing surface data objects are used for, such as defining model layers or parameterizing model elements in the expression builder. Additionally, TINs are now used on the back end to represent model horizons instead of surfaces, as TINs are a more precise method of representing these model elements. In Flex 11, you can now define inactive transport zones when using the MT3DMS, RT3D, or CWAT transport engines. For those of you who are familiar, this means that the ICBund variable can now be defined to be 0. These inactive transport zones are parts of the model where transport is not simulated and where concentration values are not calculated. This can allow for big increases in performance for transport models. There's also a long list of small improvements that we've added to the software. In this release, we've included several highly requested usability improvements. For one, you can now reorder items in the data tree just by dragging and dropping them. Runs can be given aliases and descriptions, which renames them in the Model Explorer. So this makes it much easier to document the differences in between model runs, as well as navigate in between different modeling scenarios from the Model Explorer. More coordinate reference systems have been added to the CRS database, and additionally, the CRS picker is now searchable instead of just being one big drop-down menu. So you can now, for example, type in the name of your CRS or the EPSG code and filter for it. Here's a few more features that we've added. Attribute data from points and polygons can now be used in the expression builder, as well as elevation data from points and polylines. Recharge and evapotranspiration boundary conditions can now be defined for specific layers. That is to say, we now support a value of 2 for the rchop and nevtop variables. There are several new options, too many to list here, for exporting data objects and boundary conditions from Flex. Surface and tin data can now be visualized with upper and lower transparent cutoffs. Flex is now more robust when importing or otherwise dealing with data that's in non-American number and date formats. That said, we still strongly recommend using US settings for the smallest chance of encountering issues. Horizons can now be specified directly using a constant elevation value rather than always requiring an imported surface. And there's several more features in the laundry list of bug fixes that I won't be able to talk about for time. If you'd like to see the full list, check out the Flex 11 release blog post on waterloohydrogeologic.com. If you're interested in learning more about Flex 11, I'd recommend contacting our sales team, sales@waterloohydrogeologic.com. They'd be happy to tell you more and answer any questions that you might have. If you'd like to contact me, my email is nlyle@waterloohydrogeologic.com. We're always very keen to hear from our users, and suggestions for how to improve the software are always welcome. Thanks for watching. We hope that you're as excited for the new release as we are.